Welcome to Aries Tutorial 1, Introduction to using Aries TETRA Network Performance Monitoring. In this video we will be looking at the basic functionality in Aries for viewing and analyzing TETRA network performance data. Let's start off looking at what the Aries system comprises and how the various parts fit together. We start with the TETRA network, which can range from 1 to hundreds or thousands of base sites. Connected to this network is a TETRA radio terminal, and connected to that is the Aries probe, a small box that logs all of the performance data in real time. The probe is designed to be autonomous in operation and can just be plugged in and left. Aries can use a single terminal and probe, but Aries works much better when many terminals and probes are used together, all collecting data in real time. These terminals and probes will normally be used in vehicles that are constantly driving around the area of interest. Whilst Aries probes can be used in a dedicated survey vehicle, the usual idea is to use them in vehicles that will be moving around the area anyway, so reducing the cost of data collection to virtually zero. These probes send their data back in real time through the internet using a 4G network to the Aries server, which stores the data and allows users to log in to view and analyze the data. The user logs into the server from an internet browser using a secure connection and a password-protected account for each user. A single Aries server can support many hundreds of probes and tens of users logged in simultaneously. Let's log in now to RSI's Aries server and show exactly how it works. So the Aries server is accessed as a standard web page on a browser. This is the login screen, and I'm going to log into a test account with some example data that we can use for the tutorial. And straight away we see the survey data coming up on the map. It consists of icons representing the various call events, and in this case if we click on the legend we can see the color depends on the serving site RSSI, with red currently set to show the lowest level below -90 dBm. The various call events include call success, call fail, uplink and downlink speech sample, and also a monitor event showing just the signal strength at that location rather than a call event. Looking at the options for the map, we can set the map currently to the local Aries server, which is in fact OpenStreetMap images, or we can go to Google Streets, Google Satellite, Google Terrain, or indeed no base map at all. Let's set it back to local Aries server. Now what we are going to do is add the base sites to the map, which helps with the analysis a lot. Aries includes a base sites database, so we'll add that and shut down the map layer control. Let's zoom in a bit and we'll look at one of the events and see what information is associated with that. So let's click on a monitor event and we get a pop-up with more detailed information. We have the basic event information of date, time, location, speed, even a road type, and then the TETRA information showing the serving cell, the LAC, the name taken from the Aries database, the frequency, in this case a channel number, and the signal strength, -79 dBm. It includes a full neighbor list, the best neighbor being at the top. And we can see on the map, we've got various lines going out to all of the neighbors from that event. If I just shut this down and pull it down, we can see the serving site is connected by the solid line. The best neighbor is connected via the thick dotted line. And then all the other neighbors are connected by the thin dotted lines. If we click on a speech event, in this case one of these left or right arrows, in this case a downlink speech sample, we get the same line showing the serving and neighbor cells, the same basic information, and then at the bottom we get additional information about the speech quality at that location. In this case the PESC raw, that's P.862 value is 3.076, that's a good value, and we can play that sample recorded at that location.
We need grain to keep our mules healthy. Both brothers wear the same size.
Now we'll come on to speech quality testing in a later tutorial, but for the moment we can see that it consists of a short speech sample which is then processed to produce the PESC value. We can also click on a base site and see the information associated with that, and instantly we get this another pop-up, and we get lines showing all of the neighbor cells associated with that site. Let's have a look at the neighbor details. So this is the list of neighbors that have been logged by the system, and we can see here we've got a green tick system. So if this neighbor was planned and it was used, then it gets a green tick. If it was not planned but it was detected, so this is an unexpected neighbor cell, then we get a red dot. And in the case that it was planned but never used, or never detected, at least by the Aries probe, then we get the grey dot. So instantly we get an indication of where there may be a problem. We can see here this is the summary of handovers to each of the neighbor cells, and there's one dominant neighbor site getting just over 30% of all handovers from this serving site. We can show the frequencies that have been logged for this base site, and we can show the base site details. Now this actually shows layer 2, layer 3 information, which is logged by the Aries probe when it works with a Motorola TETRA terminal. We can see the same green tick system. So if we have a value which was not expected, this does not correspond to the value in the database that we were expecting, then it highlights it with the red dot. And we also have voice quality summary. So this is all of the voice quality samples that have been logged within the coverage area of this base site. This is the average of all of them, and it's broken down into uplink, downlink. In this case, the values are exactly the same, so that shows a pretty healthy base site. We have one other function here, failure simulation mode. Very useful functionality. If we tick this, the system then works out the coverage, assuming that this base site is no longer working. And we can see that around here, the coverage got a lot worse. And it now shows the coverage from the best neighbor cell rather than the serving site. If we take it off, we can see that the coverage comes back again. So a very useful function to show how coverage will change if a single site were to fail. Let's change the analysis. We go to the configuration button and we get a box full of analysis options. We're just going to look at a couple of those in this tutorial, but if we go through it briefly, we can change the date for the events. All logged data is put into one single database, and we specify the date and time for the data we want to look at, which probes we want to look at. Base sites, we can specify only show me data from a particular base site. And similarly for areas, we can specify a polygon and then only show data from that polygon. The event types, we can specify which events we want to look at. In this case, we've selected all of them. And then in the map options, we're currently showing the icon color as serving site RSSI with these thresholds. Now, rather than having to change all these manually, a quick way is to set up an analysis profile, which has a whole set of options preset. This particular analysis profile for map 1 has the icon color set to PESC raw, which we'll have a look at that now. So now we can see the color of the icons depends on PESC raw, P.862 score, with red being less than 1 and dark green good quality greater than 2.9. And we can see almost all of the icons are showing dark green, which of course is good quality and good to see. If we zoom in, we can see the data in more detail. If we have a look at this event here, so this event, speech quality event, this is a downlink speech sample, and it has a value of PESC raw P.862 value of 2.117. If we just listen to that.
We need grain to keep our meals healthy.
Both brothers wear the same size.
And we can hear very clearly the way that the speech quality has degraded, and we get the classic metallic sounding audio because of the poor quality bit errors that we're getting at that location. So that concludes this first tutorial. Thank you very much for watching, and hopefully you'll join us for the next in the series of tutorials. Thank you.